today, I think we can maybe make an amendment to the assignment to make it a little bit easier to swallow. All right, so this is section 10.6. You do have a paperwork, homework 8 today for homework. And today is pretty heavily algebra solving. That's what it is today. Question?
I need a homework packet. I can't find mine.
A notes packet?
Ain't no way. I had it yesterday. How do you lose the whole packet?
We're only on a few tables left tonight.
Here you go.
Yeah.
All right. So we have, today we're talking about segment lengths. And just like the other day, we have 3 cases based on the intersections of things. And in fact, it's really only 2 cases. These 2 happen to be the same, the way that I talk about them. Ladies, shh. Okay. So we're talking about lengths of segments. Before this, we've just been talking about angle measures and arc measures in degrees. And so now we're actually talking about maybe the length of segment A here. It turns out that there's a relationship between these parts of segments or parts of chords and secants. So it's kind of interesting. So if we have this case where we have the intersection of 2 chords inside the circle, what happens is these get broken up in sort of a proportional way. And it turns out that the length of A times the length of B is equal to C times D. So they get sort of cut in a proportional way, and we can just set up a little equation to solve for those lengths. So it's kind of easy. So it's just the product of the parts and set them equal to each other. Type 2 and 3, she has them split up, but the way I'm going to talk about it, they're going to be the same thing. So it turns out that if you have an exterior portion of a secant line, that exterior portion, so part A, all we have to do is multiply it times the whole length of that secant line. Well, the whole length in this case would be A plus B. So it's really exterior times the whole is equal to this exterior portion, which is C, and then times the whole thing, which in this case would be C plus D. So the way I think about it is really just exterior times whole. Exterior times whole equals exterior times whole. So that's how I think about them, that I've thought about them for 20 years. The same thing applies in type 3 here, that again, she's got separated out, but I think that they're the same thing. This is the exterior tangent. That's the exterior piece, but it's also the whole piece. So the exterior is A, and then the whole is also A. So it's the same thing. And then our secant line here, again, the exterior portion is B, and the whole thing would be B plus C. So it's really just exterior times whole. So let's see, we have part times part, or exterior times whole. So really only 2 things that we need to think about to find these segment lengths today. So find each value or measure. We want to assume all segments that appear to be tangent are tangent. So if they look like they're touching, they are. And is this case 1 or type 2? Type 1. All right. We want to find BD. So that is the whole length of that chord there. So this is just part times part. So I'm going to write down part 4 times, what's the other part? 5x minus 1 equals part times part, 6 times 6 or 36. So we have 4 times the quantity 5x minus 1 equals 36. How do you guys want to solve it? Distribute? We could also divide by 4. Either way, So two options there. You could divide everything by 4, divide both sides, which would give me small numbers. You could also distribute. Raise your hand if you already distributed. Okay, well, let's just do that. So let's distribute. So 20x minus 4 equals 36. And then what do you want to do? Add 4. So we get 20x equals 40. And then divide by 20, we get x equals 2. We need to find BD. So what is the length of BD? 4 plus, so, and the x is 2, so 5 times 2 minus 1. All right, so that would be 10 minus 1 is 9, plus 4 is 13 there. All right, great. Let's look at number 4. And maybe we won't solve this one all the way out, but we'll just set it up. All right, TQ is what our goal here. TQ is just this portion we want to find right here when we're done. So just plugging back in to get that. So this again is type 1. So we just need part times part. So let's see, I'm going to start here. 14 times the other part, which is 2x plus 1, is equal to part times part. I'm going to start with the 18 just because it's a little easier. So 18 times the 2x minus 5 piece there. 2x minus 5. And then what would you want to do from here? Distribute, yeah. So we would distribute and then combine like terms. Do I need to do any more here? No? Okay. All right. So you would distribute, combine like terms, move your x's over, etc. And I think you're good for that. So let's move on to number 6. All right, which case is this one? Which type? Yeah, it's a type 2, so I need to think about the exterior portion times the whole segment length there, or the whole secant length. Number 6, we want to just find, we want to find this whole length of NL when we're done. So I want to do exterior times whole, and that's what I'm thinking when I see this type of setup here. Let's see, I'm going to start with the 10, so that's the exterior piece, would be 10. And what is the whole thing? Yeah, the whole thing is 52, so that's going to be 10 times 52, is equal to, what's the exterior on the other secant line? 13, and then what is the whole thing? 13 plus x. 13 plus x, or x plus 13, adding lengths together. So we get x plus 13 for the whole thing. So be a little bit careful when you're doing that. Yeah, so we're going to distribute that 13. I get 13x plus 169 equals 520. 10 times 52, 520. And then we need to subtract the 169, which is going to give me 351 equals 13x, and then divide by 13, and I get 27. So to find NL, what do I need to do? Yeah. It's right here, so it's just 13 plus 27, which is going to be 30, 40. Okay. Questions so far? Are you pretty good? Pretty good? All right. All right, let's turn the page. And let's look at number 8. Again, this is type 2, which means I need to look at what times what? Exterior times whole. Very good. Exterior times whole equals exterior times whole. So I'm going to start with the exterior piece here, which is 12. And what is the whole? Yes, 12 plus x plus 8, which would be? X plus 20. Very good. So the whole thing becomes x plus 20. I think it pays to just write that on your paper, just like I'm doing here. On the other side, what is the whole? Yeah. 15 plus x minus 1, which would be?
X plus 14.
X plus 14, yeah. All right, x plus 14. So exterior is 15, and then the whole is x plus 14. Okay, are you good? Do you have any questions?
No.
All right. Do I need to do this one? What is your next step?
Distribute.
Distribute? Okay, great. So we can distribute. All right, good. We don't need to do that. Again, setup is most important here. All right, let's look at number 10. Is this any different?
Yeah.
I mean, it's type 3, but do I have to think differently?
No.
No, it's still exterior times whole, which is kind of nice. When we look on the secant line, what is the whole? 5x plus 7. Yep, 5x. And then negative 1 plus 8 gives me a positive 7. So the whole would be 5x plus 7. Okay, so starting with that secant line, what's the exterior? 8. And what's the whole?
5x plus 7.
Yeah, 5x plus 7. And that's going to be equal to my tangent line here. What's the exterior? 16. What's the whole? 16. Yeah, so it still works the same exact way, which is kind of nice. And so I'm going to just go ahead and distribute. We're going to get 40x. What's 8 times 7? 56. Good, just making sure. 16 times 16? 256. Very good. Oh, hey, this is easy. Let's subtract 56. What do we get? 200. Hey, how about that? And then divide by 40, we get? 5. Good. All right. What? What did you say, June? All right. PN. PN is right here. That's what we want to find. So what do we need to do? 5 times 5 minus 1 is 24. You good? Okay. Let's look at number 12. All right. What is the whole here? 25. 16 plus 9 is 25. So same thing. This is just exterior times whole. So what's the exterior? 9. What's the whole? 25. And then on my tangent line here, what's the exterior? 3x. And what's the whole? 3x. Okay. All right. 9 times 25 is 225. Very good. And what's 3x times 3x? Ooh. 9x squared. Yeah, 3 times 3 would be 9x squared. How do you want to solve this?
Divide by 9.
Divide by 9. Very good. Divide by 9. We get 25 equals x squared. Good. Then square root, we get x equals 5. Beautiful. All right. So that's great. Now becomes the hard part. Those were easy. Let's look at 13. Which type is this? Type 1. So what's our little process for type 1? Part times part. Yeah, part times part. So that's easy. Let's start with the 12. 12 times 10, so that's piece times piece equals, yeah, x plus 6, that's one part, and then the other part would be x minus 1. All right, what do we need to do with these bubbles next to each other like this? FOIL them, distribute, yes, so they are being multiplied together. Over here we have 120. I'm going to go ahead and I like the word distribute because it's just nice. What is x times x?
Squared.
X squared. What's the outside? Negative x. X times negative 1 is negative 1x. And then we got to do the inside here. Distribute this. Yep. Positive 6x. Good. And then positive 6 times negative 1?
Negative 6.
Negative 6. Good. I want to clean this up, but it's also quadratic because of the x squared. How do we solve when we have an x squared like this? Well, that's when there's the x squared is all by itself. Like we are going to have an x term. How do we solve it when we have an x squared and an x and a number? We have to do something with this 120. We have to move it over. When we have a quadratic like this, we have to set it equal to 0. And that's the thing we need. Set equal to 0 for these kinds. So I'm going to do that. I'm going to subtract the 120. So I get 0 equals, I have x squared. I have a negative 1x and a positive 6x that I need to combine. What does that become? 5x, so plus 5x, and then negative 6 and negative 120 gives me negative 126. So this is the important part, that we are set equal to 0. And then from here, we have a trinomial. What do we do?
Add 126.
No. Double bubble. Yes, double bubble. Okay. We do have to double bubble. What times what? First times first has to be the first thing. What times what is x squared? X times x. And then 126 is a challenge. I want to show you guys. I don't know all my factors, especially numbers bigger than 100. That's, I think it'd be a little bit bizarre if we knew all the factors of 126. But I'm going to give you a little bit of math analysis lesson. All right, I had to go to college for this. If I want to figure out the factors of a large number, the first thing I'm going to do is take a square root of it, because it turns out that all the factors I can find are all numbers that are less than this. Okay, so I'm going to take the square root, and it says I'm just going to check all the numbers under 11. Okay. And if I do that, that'll give me all the factors. So all I really have to do is say, hey, I'm going to take 126, I'm going to divide by 11. Does it go evenly? No, it does not. So 126 divided by 10. 12, that didn't go evenly either. 126 divided by 9. So it's just a nice little way to figure out your factors if you don't know them. I'm no genius. I didn't know them either, so I went through this exact same process. And I could keep going. 126 divided by 8. Nope. 126 divided by 7. Hey, there's another. 7 times 18 is also 126. And I could keep going. So there's no real, there's 6 times 21. It's just brute force. That's all. There's no genius involved in this. It's just checking, hey, 3 times 42. And maybe after you do things a while, you'll figure out, if I took the 2 from the 6, then that leaves a 3, double the 21. Like maybe you'll figure out some little patterns like that, okay? And then, of course, it is divisible by 2. But, so the square root thing, all your factors are always going to have ones that are under that. Okay, and so you don't have to check all the numbers from 1 to 26. So we get to 1 to 126. Get to save ourselves a little bit of time. So there you go. If you don't know, now you know. So which one looks like a winner for us? 9 and 14, yeah. So if we had a positive 14 times negative 9, that would give us a negative 126. And it gives us a positive 5 when we combine them. So positive 14 and negative 9. And once you get your bubbles, we need to solve. So what are our solutions for x? Positive 9, good. So negative 14 and positive 9. Can I have, if I plug in negative 14 plus 6 is negative 8? Does that make sense? Can a length be negative? No, that makes no sense. And negative 14 minus 1 is negative 15. That really doesn't make sense at all. We cannot have lengths that are negative. So I need to get rid of that answer because it does not make sense in the context of this problem. Okay? 9 is fine. 9 minus 1, that give me a length of 8 and 15. So check your answers. Make sure they make sense. Let's try another one. Let's look at number 15, and then we'll be done. What's my recording time right now? 21? Okay, that's not too bad. All right. What case is this? What type? Type 2, so what's my little thing to remember? Exterior times whole. Exterior times whole. So right here, what's my whole? What's the whole length? X plus 15. Very good. And over here, what is the whole thing? 28. Yes. All right. So exterior times whole, that means I'm going to have X times X plus 15. Yeah. Exterior times whole. And then on the other side, we're going to have, what's the exterior? 5.5 times the whole? 28. Okay. So I'm going to go ahead and distribute my x. X times x is x squared. X times 15 is 15x. And 5.5 times 28? 154. All right. So what do we need to do to solve? Yeah, set it equal to 0, so we're going to subtract 154. So we have x squared plus 15x minus 154 is equal to 0. Very important that we get that set equal to 0 so that we can double bubble. All right, x times x is x squared. So what's the trick? 154 is pretty big. So how do I figure out my factors? Square root of 154. So I'm going to check numbers 12 and under. Okay, so 154 divided by 12, nope. 154 divided by 11, oh, hey, look at that. 11 times 14 equals 154. 154 divided by 10, is that going to work? No, that's not going to work. It has to end in a 0 to be divisible by 10. So 154 divided by 9, maybe. Nope. 154 divided by 8. Nope. 154 divided by 7. Hey, 7 times 22. All right, 154. Oh, I think that's a winner, isn't it? Yeah.
Why?
Because I want to get something that is negative 154. So positive 22 times negative 7. Positive 22 times negative 7 will work for me. And when I combine them, I get 15. All right. Positive 22 and negative 7. What are my solutions for x? Good. And which one makes no sense at all? Negative 22 makes no sense, so we have one solution there of 7. All right, ladies and gentlemen, do you have questions for me? Is this a neat trick to be able to figure out the factors? Is that helpful? All right. Fantastic. Let me pass out your homework now.